Hey guys, Mr. Riz here to help you out with the 213, and this is going to be part one. Where we're going to look at is the password strength, and we're going to try to make it strong. So in this whole activity, some of our goals is to make sure we can learn how authorization and authentication measures and protects data. Um, we're going to also analyze and modify code that is designed to crack passwords too, to understand what strategies strengthen our password protections. So let's first look at like what's weak versus strong. So did you know that almost all security problems on the internet are caused by individual people? All right, if everyone took just greater responsibility regarding their personal security measures, the world's largest network would be, very safe. For example, many security breaches can be traced to users creating really weak passwords and system administrators using really weak security measures. All right, this allows malicious users to access systems where personal, financial, or national security information is stored. So in this activity, we're going to learn the differences between weak and strong security measures. And we're also going to learn how all of us can improve the security of the internet. All right, first, the easiest protection measures an individual can take is to always use a strong password. Any system on the internet with a weak password makes the entire network just open to misuse. You can think of the internet as like a chain, and just one weak link of the chain just ruins the whole chain. All right, malicious users can easily access one system using easy to get passwords and then use that to exploit the entire network. So if they get onto one of them, they can use that link and get onto more and more. So what's a weak password and what makes a password strong? All right, first off, we're going to look at a single word password, which is usually always the weakest password you can choose from. So let's explore why. Let's go ahead and open this code up here, and I'm going to split screen so we have our notes on one side and our code on the other side. And you can see this code has a main py file here. We could change this from to py and an analyzer, but we can kind of do like we did on our last activity, just to remember that this is our main py. And then we have some other ones here. We have a huge dictionary list of a whole bunch of passwords here. And then we have another py file that we might use later on. So let me go ahead and fork this. So if we change the code, and can I fork this here? Fork. There we go. Okay. So here we go. You may notice that we got a new algorithm here. And if we kind of take a look at this, main while we get password, insert password. We're going to analyze the password. Time equal time dot time. Okay. And then we got some other things going on. Line 9 saves, is it actually line 9? I don't think that is line 9. Saves two return values. That's actually would be line 11 in my case here. The first is a Boolean value that indicates whether a word was found. And the second value, num guesses, stores the how many dictionary words the algorithm had to search through to find it. So here we go. Next, the other lines of code should be familiar with you. So like if this is found, so if we get a true statement here, then we're going to say found in and number of guesses. Else, if it's not found, not any guesses. And then we have a time. So kind of goes through. So let's review the P algorithms module here. And is that the one we're looking at? No, that's this one here. So let's review the one word function to describe how it analyzes one word. All right, so we're looking at this one here. So we get words equal get dictionary, and the get dictionary basically goes to makes up blank text words. All right, we get their dictionary file, which is right here, and for every line in the dictionary file, we add that to the end of the list. We append it to the end of it, so we don't, or when you append it to the beginning, that's what the negative one does. All right, and then we go and we return those words. Okay, so words become that words here. All right, guesses equals 0 for every W in word. So every word in this word list, guesses go up by 1. If W is equal to the password, which is what the person typed in, we return true for the guesses, else we return false and how many guesses. So review the dictionary function. All right, the function of this list. What is in this list? So basically, we kind of went through this here. What is in this list? This is a list of every single password here. And we can see about it. I don't know if you guys know too much about passwords, but this looks to be a list of the most common passwords in order. So let's see, 1, 2, 3, 4, 5, 6, password 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. A lot of the most common passwords. Okay. Some of them are crazy beefcake. And just to find some of them in there. I was like, oh, and then there's just a whole bunch of dictionary words after that. So it looks like it's a list of the most common passwords followed by just like a dictionary of words. Yeah. Okay. Next, all right, the dictionary file, okay, contains 26,000 entries. Many words found in the English dictionary, approximately 5,000 common passwords. So after that, yeah, after 5,000, yeah, we just start doing the dictionary. All right. So for example, the top 25 passwords in use today are below. So we can see all those common ones. For in this activity, all appropriate words and phrases have been removed from, or inappropriate words. So you're not going to find any colorful letters or words in there. However, just because they are not included in this list doesn't mean that they can't be a password. So yeah, people still use those as passwords. All right, so using the dictionary file, we will compare the time it takes for your program to discover and match the different types of passwords. To get a good analysis data, we're going to compare the average times to this. You should analyze the passwords from the middle of the dictionary file, not at the very beginning to make the shortest time match, or at the very long. So we're going to run the program and the password analyzer program, which is our main py file. And yeah, we're going to enter the password for koala. So it says enter password here. We're going to type in koala, if I spelled that right. Okay, and it gets at about 15,000 guesses. I got 15,183, and the time took about 0.03. No, yeah, this definitely took longer than what this took because we're running this on Ripple. That's just how it was. I guess if we were running this straight on computer, probably run a little bit faster. This tough time represents a rough average of searches and why. Yeah, it goes through. All right, what about an offline brute force attack? So when malicious users try to just randomly guess passwords, it's called a brute force attack. They have no idea. They're just going to keep trying until it works. I mean, the computer can do things super quick, so it might not take a long time. So most computer systems don't allow for thousands of password guesses. You can think about like on your phone, you probably have so many guesses and then it locks out. However, password files can be stolen and then the analysis can often be done offline. So even though that they can't do it online, they can steal that information, put it offline and keep trying a million times until they get it right. So let's talk about like the ethical scenario of what we're doing here. So analyzing passwords for the good of the user is not the same as just cracking passwords for malicious intent. All right, you should never analyze someone's password without their consent. You shouldn't just do it and be like, hey, I cracked into your email. You should really change your password. You probably let them know. To do so means you are cracking their password and committing an unethical and often illegal act. So this is kind of that gray area here. You should always inform somebody if or ask them if they want to check their security of their passwords before you just check it for them. All right, what about two-word analysis here? So to make a brute force attack more difficult for users, malicious users, you can often strengthen your password. For example, you can use 2 words and not just 1 word password. So technically this makes it what's called a passphrase. So if we look at the 1 word function in going back to this one here, define 1 word function. All right, you can strengthen your password. I'm going through this. So reviewing this one here, sorry. We're going to try to think like as a starting point, a brand new algorithm that contains possible 2 words in the password by combining the words from the dictionary file. All right, so try to think about the strategy of how to do that. So take some time right now, like maybe jot it down on a piece of paper. If we wanted to make a new function here called 2-word, which gets the password and then checks in the words from the dictionary here, not just like if the 1 word is in but then also if the two words, if we can find both of them in that passphrase. Okay, so take a second right now, maybe pause the video and go ahead and jot down some pseudocode of how we do this. If you're in class today, that's what we're going to do on the board. Try to together think about a way we can turn this into a two-word passphrase. Okay, so if you think you have an idea of how to do this, or if you're stuck, let's walk through this and try to make sure we kind of understand everything about the code too. So one thing about the dictionary here, it uses base words. So it doesn't have every single word in the dictionary, but it rather has base words. So it has apple and not apples. So we don't really need to worry too much about, the S at the end there. It also has just the base form of a verb. So it has explore, but it doesn't have explored or exploring. So we're going to use the password analyzer to test our functions, and we're going to add an algorithm. So a good way to do this here is to basically, let's copy one word, Control C, and make a new one called two word. Right. All right, next what we want to do here is to, we'll have to go through and then change this here. Instead of writing one word, password, we're going to run two word. Because remember, our main PY file, after we type in the password, it will run the one word with the password. Now we're going to run two words. So now we're going to make sure, now right now it will do the exact same work. So if I type in koala, it technically will run the password, the two-word password function, but that's right now the exact same thing as the one word. Okay, so this is probably not the best technique, but it's an efficient technique. What we can do is just basically start with every word in there and then just tack on the end. So if I have A, the password, was it, apple, apple. All right, was it apple, banana? Was it apple, carrot? Was it apple, donkey? Apple, and then go all the way through apple and then check to see, well, then is it banana, apple, banana, 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 carrot, banana, donkey, banana, elephant? All right, that doesn't work. All right, let's move on to carrot. Carrot, there's a carrot, apple, carrot, banana, and it's going through all those. So we might want to go ahead and make our phrase the connection of two words together. So if we think about this right here, we get all of the words in our dictionary. We make a giant list from the words equal get dictionary from back up here. And we have guesses equal 0. Just start initializing this. Now, what we're doing first is just seeing if that one word was in that list. Well, now what we're going to do is have like two separate words, word 1 and then word 2. All right, so for every, maybe we'll say word 1 in words. And then what we'll do here is inside of that, make for every word 2 in words. So that means, and I'm going to shift all this stuff in. Maybe I just need to shift that in there. Yeah. We're going to go through, start with the first word, and then we're going to change the second one as we go through. And then we'll change the first one, and then we'll change this, go back over and change the second one. All right. We want to go through and check to see if the password equals W1 plus W2. Okay, now that should be, now there might be some syntax here that we might want to change, but let's see, guesses would go up. So each time we change word 2, our guesses go up. First guess, second guess, third guess, fourth guess, and we shift that down. Next guess. Okay, so the guesses keep going up each time. We're seeing if these two put together equal that. So let's just make 2 words together. How about koala bear, and see how long that takes. All right, so let's run this here. Password koala bear, not beer, bear. Analyzing password, definitely taking longer here. So it's going through each one of those, and it takes what, 15,000 before it gets to koala, and then it's going basically through. Now this is definitely taking a while here. We'll see. It's running. I guess if we were really worried, we could just have it print off guesses each time to make sure that it's still running. You know what? In dictionary, I don't know if I just stopped it, but is bear in here? Control F, B-E-A-R. Bear is in here. All right. I wonder if this is Ripple. So let's try this again. Let's stop it. Let's run it again. Let's enter a password. Let's just kind of do something we know that's going to hit real quick. We should know that. Let's go look at our dictionary here. What's one of the first words up? Let's do password and then 1, 2, 3, 4. Yeah. It shouldn't take too long to find. Well, I guess, yeah. Enter password. Password 1, 2, 3, 4. So, oh, it found it in 26,000. So more guesses than just koala. It took a little time. I guess koala bear took forever because it went through every single one of those. Oh yeah, 15,000 times 15. So really going through and multiplying this here. Once you guys get this done, go ahead and send this Ripple link in here and try it again. Let's try to get something a little bit further down in the dictionary. How about baseball, football? Baseball, football. Oh, that took really quick. How about something way down here on the line? How about just 2 words that start with the letter A? How about bark and doxy? I have no idea. Oh, bark, doxy. So this is taking a while. It's got to go through all the 5,000 common ones. I'll pause this video and let you guys see what happens. All right, so I got it done there. It took, let's see, how many guesses is that? 1, 2, 3, 172,438,603 guesses, and it took 84 seconds to find that out. And those were 2 words that were up there pretty high. So yeah, if we definitely did koala bear, that would take way longer. So submit your Ripple link here, guys, and we'll see if you guys got that right. And then we'll talk about this. So I will see you guys for the next activity when we learn to make our password even stronger. Have a good one.